What's up, math scholars? We're making a video to help you on the study guide in case you need to re-watch it to study. Re-watching the video like the night before would be a great way to study. And doing the study party problems would be a great way to study. And attending a study party is always recommended as well. So one of those would be after school Thursday and then again before school Friday. Or a lot of people come second period because I am free second period. So for one ticket, can I have a volunteer do what we did yesterday and just spin around this circle, giving me all the degrees? Ryan?
Sweet. You started at 360 or 0, whichever you prefer.
Okay.
You go to 30, 45, 60, 90. Get it right. 120, 135, 150, 180, 210, 225, 240, 270.
Okay.
300.
This is on video, live on the internet.
330.
All right. So we don't need the sound effects, but thank you, Luke. All right, Ryan did great. That was Sam. I'm sorry. Luke was the one laughing, so I thought it was Luke. Sorry.
The sound effects.
All right, I'll get a new color, and we're gonna go around. This time, doing all the. How about let's do all the coordinates at the hot spots, those quadrantal angles. So we'll do the coordinate here, we'll do the coordinate here, we'll do the coordinate here and here, because those ones are pretty easy. They don't require much memorization, just a little bit of thinking. Kayla?
1 and 0.
Yep.
0 and 0 and 1.
Perfect.
-1, 0.
Yep.
And then 0, -1.
Perfect. So you can just think, do I need to travel right or up to get to those spots? All right, let's next do all the ones that I'm about to put a blue dot on. So let's do 30 degrees, 150, 210, and 330. They'll all have the same coordinate, but you'll have negatives on different spots in the coordinate. Does somebody want to try that? Let's go with Marcella. Uh-huh. Yeah, and I remember that because radical 3/2, by the way, people on the internet, is 0.866. So to get to this blue dot, she had to go really far over. So 0.866 over, but only a little bit up. So 1/2 is equal to 0.5, and that's what I would call a little bit. All right. Now let's start spinning, Marcel. Keep helping me. This one over here is going to be reflected, so it's also a radical 3/2 and 1/2. But which part of it would be negative, the x or the y part?
Yes.
Perfect. Let's reflect down to our 210. It's also radical 3/2, 1/2. But what is going to be negative, x or y? Both, because we're in quadrant 3. Both of those are negative. And then 330, radical 3/2, 1/2. The y is negative. Perfect. Here is your ticket. All right, so that's blue. If you want to use highlighters like on the quiz to help you organize colors, that would be awesome. You're allowed to do that. How about we do green? 45 can be green, 135 can be green, 225 can be green, and 315 can be green. So I think Hannah's going to help me out with the greens. Go for it.
Radical 2/2. And then radical 2/2.
Perfect. Hannah, do you remember the decimal equivalent for radical 2/2, just to help our audience? 0.707, real close. So that basically means go 0.7 over and 0.7 up. It's an isosceles triangle that would fit in there. So let's start reflecting. You're going to help me, Hannah. This would also be radical 2/2 and radical 2/2. Who should be negative? Awesome. 225 would be radical 2/2 and radical 2/2. Who would be negative? Awesome. And 315 would be radical 2/2, radical 2/2. Who would be negative? Awesome. Here is Hannah's. How are you doing filling out our circles? So great. We have all of our... Okay. Let's do... the only color I haven't used is black. So let's do 60, 120, 240, and 300. We'll make those black. Who would like to do it? Who would like to be my helper? Connor?
Yeah. Radical 3/2.
Yeah, so it's just what 30 degrees was in reverse. So let's start reflecting.
-1/2.
The 1/2 out front will be negative. I agree. What about down at 240?
-1/2 and negative radical 3/2.
Perfect. And then what over at 300?
It's going to be 1/2 and then negative radical.
Very scholarly. All right. All right, so that is the non-calculator part of the quiz. After you fill out your circle, there will be a few. I forget if it's 5 or 10. I almost feel like it's 10 questions you'll need to answer. Now keep in mind, you do not have a calculator. So like when we get down to sine of 600 and you're going to want to subtract 360, you're going to have to do that by hand. So you know, borrowing and carrying and all that fun stuff, right? So let's start with the sine of 135. You just find 135 on your unit circle and you grab the y value. What would that be? By looking at 135 and grabbing the y value. Right? So it's radical 2 over 2. You understand?
Yeah.
Oh, okay. I thought you were like being serious. You just never know. Let's go to 90. Found it right here. What's the x value? Because they're asking for cosine. So you do need to have memorized that cosine means x, sine means y.
Can we put a 1 under that?
No, you could, but if we did that yesterday mainly because we were doing reciprocals and we were then doing secant. So having the over 1 would help us flip it. That's fine. That was helpful in the homework. All right, negative 60. If I would spin negative 60 degrees, I would land probably about here at 300. So what's the sine value at 300? Negative. Radical 3 over 2, the y value. Yep. Oh boy, negative 210. We can either figure out how to spin negative 210 degrees, or we can just add a 360. That's probably what I would do. If you add a 360 to a negative 210, it's the same exact thing as 310 minus 210. So it's 150.
Yeah.
That's probably going to be a little bit easier. So let's change this to 150. We're going to take the cosine of 150, then at the very end, change the sign. That's what that negative out front means.
Negative 3 over 2.
So 150, the cosine of 150 would be negative radical 3 over 2. But this negative out front means change the sign at the very end. So positive answer, or our final answer is positive radical 3 over 2. I'm really running out of space over here, so I kind of apologize. Here we go. I fit it on. And then 600.
240.
Hopefully we remember how to do subtraction the old-fashioned way with borrowing. 600 minus 360. So I would do 0 minus 0. I would do 0 minus 6, which I can't do, so I would borrow 1. So that 6 becomes a 5, and this becomes a 10. 10 minus 6 is 4. And 5 minus 3 is 2. 240. Awesome. So we're basically going to find the sine at 240, because 240 is the same thing as 600. Where's 240? Can you find it?
It's right, the third quadrant.
Right here, third quadrant, black dot. So the sine value is the y value. Negative, radical 3 over 2. Any questions on those ones? We probably should have done a couple tangent practices, huh? But I think we'll get tangent practices later.
It's okay.
You want to do a tangent practice?
No, I think we're
No.
Thank you.
Okay. I think we'll maybe do a tangent practice during the study party tomorrow. I mean, we still have all day tomorrow to review. So we'll do some we'll hit up tangent hard tomorrow. That sound good?
We do groups tomorrow.
Get it up.
Yeah, we're probably going to do groups and board buddies and stuff like that. All right. How are we doing? Do you need me to pause and give you more writing time? Are we ready to rock? Ready? Alrighty. So they're asking me to do sine, cosine, tangent, cosecant, secant, and cotangent from this scenario. So what do we want to do? Who has some ideas? We're working with theta. Let's talk about that. We're working with theta. Is 4 going to be an opposite, a hypotenuse, or an adjacent?
Jason.
Very good, because it's right beside your theta. Is 9 going to be an adjacent, a hypotenuse, or an opposite? Good. So it looks like we're missing our opposite side, are we not? How about we just call that x, and we start by solving for x, using the Pythagorean theorem.
4 squared plus x squared.
All right, so here goes. 4 squared plus x squared equals 9 squared. That would be 16 plus x squared equals 81. We're going to subtract that 16 over. So 81 minus 16 would be 65. Slow it down a little bit.
That'd be-
Well, we don't want to square root the 65 and get a yucky decimal. We want like an answer in radical form. So be radical 65. Now, do you guys think anybody could break out of jail? 65 is 5 times 13, so I tried as well, so nobody can break out of jail. So my opposite side I'll be using on all my ratios is square root 65. So I think we're ready to set up our ratios. Reese? Oh, Jake?
Yeah, why don't we make it like 8.06 to...
We want like exact answers, not approximate answers, so you want radicals, you know?
I see. Oh, yeah, I see.
The minute you do like 8.8 or 8.1 or whatever you told me it was, 8.2.
What type of triangle, what type of problem we do when we want that answer? That we trying to find the
Probably like one of those problems where they say find the length of the arc length and stuff. You can have decimals. But other than that, just keep no decimals, exact answers. All right, so sine of theta, opposite over hypotenuse. Opposite over hypotenuse. I'm writing that there to help you refresh what it is. So my opposite side of theta is radical 65, and my hypotenuse in my triangle is 9. And that's all you have to do. I don't need you to reduce that any. In fact, it doesn't actually reduce any, so that's all you can do. All right, cosine theta. Let's use a new color. Adjacent side over hypotenuse. So what's my adjacent side? 4. And my hypotenuse side?
9.
And that's it. You don't need to reduce that. You cannot reduce that, actually. Go with green. Tangent is opposite over adjacent.
Radical 65 over 4.
Radical 65 over 4. Now for one ticket, who knows how to do the last 3, and you can run down and tell me those answers. Ian.
Cosecant or whatever, 9 over square root of 65.
Yeah, it is cosecant. He's right.
4 over 9.
Oh, we already have 4 over 9, I think.
Or 9 over 4.
There you go. Okay.
And then 4 over square root of 65.
Good. Perfect. So you just flip your top 3 in order. Reciprocal them. Reciprocals. All right. They're asking us to find tangent if you know cosine. My advice is this is referring to a triangle, correct?
Yeah.
Let's sketch out a triangle. Sketch out a right triangle. I don't care what your right triangle looks like, if it looks like mine or not, but sketch out any right triangle you can think of. Make sure you put your right angle in there, and make sure you put a theta in one of the corners. So my theta is going to go there. Yep.
3, 4, 5 times.
Oh, it's a 3, 4, 5 triangle. You figured it out already.
Yeah.
Such a scholar. You can have a ticket for that. You must have got an A in geometry.
I didn't.
Or you just paid attention this week.
I
All
got
right.
a...
So when I drew my triangle like so, and I put my theta where I put it, when they gave me that cosine theta was 3 over 5, that was their way of saying the adjacent side was 3 and the hypotenuse side was 5. And maybe that is how Jake realized, oh my gosh, if the hypotenuse is 5 and one of my adjacent side is 3, that means this has to be a 4. Now if you don't recognize it right away, because you don't know what 3, 4, 5 triangles is, you can solve for x by doing a quick Pythagorean theorem. X squared plus 3 squared equals 5 squared, which 5 squared is 25. I accidentally just wrote 25. You can subtract the 9 over, get 16, square root both sides, figure it out that it's 4. But yeah, I feel like you're all at the place in your math career that you should recognize 3, 4, 5 triangles. Your math career. You're not in 8th grade anymore, you're in Algebra 2. You're getting up there in life. Alright, so we've got our triangle labeled. Now we need to answer the question of what would tangent of theta equal? Tangent of theta would be opposite over adjacent. So what would my fraction be? Reese.
4 over 3.
Perfect. You can have a ticket.
Yeah.
Thank you for not blurting it and raising your hand like a good student.
Oh, you're so welcome.
Yep.
Question.
Alrighty, we're going to number 3. The students were negotiating how much of the study guide we're going to get done today, so we will see, but most likely this will be a 2-part video. Alright, so we're solving for x. Who has ideas? I'll run you through my options. Sine, cosine, tangent, or Pythagorean theorem. Not so much for Pythagorean theorem. Tangent. Austin said tangent. Does everybody agree? I believe he's right. But he blurted it, so no ticket. It's okay. We do have an opposite side and an adjacent side, because one's across from the 33 and one's right beside the 33. We don't know anything about hypotenuse, so that's why we don't want sine or cosine. So let's do tangent. Tangent of an angle is the opposite side over the adjacent side. I'll go ahead and put all my data in. The 33 is the angle measurement, so that's your theta. The opposite side's 15, and the adjacent side's x. So it's come to my attention that some of you in geometry, your teachers do this a little different way, and they just kind of flip-flop some things. You can do it whatever way you learned how to do it, just get me the right answer, okay? The way I personally learned how to do it is anytime I saw a variable in the bottom, I use multiplication to get that variable out of the bottom. And then I just learned to get x by itself to divide the tan 33 over to the other side. Okay? But yeah, if you use a different method, that's fine with me. So divide both sides by tan 33. You do want to make sure, this is the first question we've come to, that if you're in the wrong mode, you'll get the wrong answer. So make sure you're in degree mode, real quick. I am. So 15 divided by tan 33. 23.1? Yeah, round to tenths or hundredths. I like hundredths the best. I'll pause it so you can catch up. Oh, we're back recording. We're going to solve the triangle. That means find every missing part. You might need to put a theta in. I can't remember if I put it in before I printed your study guide. I did. Awesome. So we're going to solve for theta. I would actually do that first. And then we're going to solve for m and solve for n. So how can we get theta super quick? Jake?
So you had 37 plus 90, is that equal to 180?
Right, you would do 37 plus 90 and subtract that number from 180.
Yep.
So 90 plus 37 is 127. Subtract that from 180. 53?
Yes.
So theta is 53. There'd probably be an answer blank for all of this information. So you would just say theta is 53, and then you'd need to get m, and then you'd need to get n. So you'd need to do all three. Now once you have that theta is 50, oh, it's 53, but I wrote 57. Sorry about that. Once you know that theta is 53, it opens up more possibilities for who you're going to solve for when. There's tons of options. Who has an idea that we can roll with? Jake?
I started off with 37. I did the cosine of 37, which is adjacent over hypotenuse.
Okay.
12 over n.
So his setup is cosine 37 equals 12 over n, because 12 is adjacent to the 37, and n is the hypotenuse in this triangle. Everybody agree with his choice before we roll on?
Yes, I agree.
Okay, everyone agrees. So talk me through solving it then.
So I'll multiply by n.
So that gets the n out of the denominator. That's a great idea.
Divide by cosine of 37.
Divide cosine by 37 on both sides.
Then 12 over cosine of 37.
Give me 1 second just to pick up my calculator.
15.02.
15.025. So let's go with 15.03. That's n.
Let me just, I'll just say the hypotenuse. The Pythagorean theorem.
Show Sam.
So we got 15.03 here, and he decided he wants to finish it off with the Pythagorean theorem. That would work. If you want to, though, you could do another trig function. You could do, like, sine of 37. Or you could do tan of 37. There's a lot of options. Do you guys want to do Pythagorean theorem like Jake?
Yeah, sure.
Okay. So 12 squared plus m squared equals 15. And I don't want to round it too much, but I am going to use the Pythagorean theorem. So maybe 0.256, like that. So if I square that number, I get 225.77. And I'll subtract over 144. Because 144 is what you get when you do the 12 squared. So yeah, that gives me 81.769, and then square root both sides. 9.05. Ooh, boy, it's not lined up good up there. Okay. So let me pause the video and let you catch up with your work real quick. Just want to minimize my video. All right, a lot of negotiations, but the dictator has spoken that 5 will be our last problem. All right, 250. Is that located on your unit circle? Oh, because if it was, we could convert it real easy just by looking, right? So since we can't just look to convert, we got to use our conversion table that's up on our board right now. So our conversion table says if you're in degrees and you want to go to radians, you're going to multiply by pi over 180. That would give us 250 pi over 180. And you can just cancel out the 0. And then does 25 and 18 have anything in common I could divide out? No. So it's just 25 pi over 18. That's easy. Move these little boxes out of our way. Like I'm always moving boxes. All right. Part B is 6 pi over 5 on the unit circle. No. So it looks like we cannot convert just by looking at our unit circle. We can convert it by hand. So 6 pi over 5. We are going to multiply by 180 over pi. Just the reciprocal of what you did in part A. Well, this was part A, now we're on part B. I love part B and going from radians to degrees because I can always just slash my pi's out. So slash that pi out, slash that pi out, and then use your calculator. I seem to have lost my calculator in the last couple minutes, so here it is. So 6 divided by 5 times 180. Did you guys get 216 degrees? All right, thanks to all my viewers for watching the video. This is a great study tool. Make sure you click subscribe. Woo! Thanks for the round of applause from one person. Hope you have a happy Wednesday and talk to you later.